Perhaps now we should look at transformations of logarithmic functions. And we can see here that this is the form of our logarithmic function. F of x equals a times the log base b of x minus h plus k. And what does all that mean? Well, let's start with the a. The a is the coefficient out in front of the log. And if a is less than 0, it's going to reflect that graph across the x-axis. So we'll see a reflection if a is less than 0. Now, if the absolute value of a is greater than 1, the graph is going to be stretched vertically. And if a is between 0 and 1, greater than 0 but less than 1, we're going to see the graph to be compressed vertically. So that's the effect that a has on our logarithmic function. Now let's deal with h. And h is a little bit tricky, particularly because of the way this reads. If you look, we see this as x minus h. Well, if x is positive, this is what it's, h. If h is positive, then it moves the function that number of units to the right. But remember, what this is really saying, when it's saying h is positive, it really would be like this, h minus plus h, positive h, which is just going to appear as x minus h. So you might think that negative x, like every other transformation we've ever looked at, when I'm inside the parentheses, inside the grouping symbol, if I see negative h, rather than moving it that number of units to the left, it moves it to the right. And if h is negative, it's going to move it to the left. Actually, the way that would appear would be x minus negative h. Okay, which then would be, we would see written as x plus h, if you catch the drift of that. And that's going to shift it to the left, towards the negative side, because in fact, h is negative, even though it appears to be positive. I know that can be confusing sometimes. Think the opposite way. Now, fortunately with k is a vertical translation, up or down. If it's plus, we're going up. If it's down, we're going down. Now, we're getting ready to graph these two functions that we see here at the bottom. But before we do, let's just take a look and let's anticipate what we are going to see. Well, this 2 here in this first function is going to stretch that graph vertically. It's going to pull it up. And this 2, x minus 2, is going to give us a translation to the right. Now, that would affect our x-intercept. That's going to affect our asymptote. So our asymptote will no longer be, should no longer be at x equals 0, but x equals 2. We should see our, I think we'd see our x-intercept go from 1 to over to 3. I hope I'm right about that. We'll verify that in a moment. And so those are the things that we should see in that particular translation. Now in the second one, a is 1/4. And I see that if a is less than 0, then it is going to reflect it across the, excuse me, that's not less than 0. It's between 0 and 1. Excuse me. It's between 0 and 1, and so it should compress our graph vertically. Then I got a horizontal translation. This positive 1 right here, which is really a negative 1, is going to move it to the left 1 unit. That's going to affect my asymptote. My asymptote will no longer be at x equals 0, but it would be at x equals negative 1. And it should move my x-intercept from 1 to 0. And then we've got a vertical translation down of negative 5. All right, well, let's go graph these functions and see if that matches what we are, or I am, anticipating. Are you ready? Does it matter if you're ready? Not really. We're going to do it anyway. Well, let's go over here into y equals, and let's graph these two functions that we had. And the first one was 2 times log base 3. So I'm going to go to math, and then I'm going to hit second math for A, option A. That's the log. And let's see, we got log base 3 of, what was it? X minus 2. And let's go take a peek at the graph. All right, so we have seen that we see our horizontal shift. Our asymptote now is here at x equals 2. It has moved my x-intercept from 1 over to 3. And if I graph this beside the parent function, we would see that this has actually been stretched vertically. And let's go verify that asymptote. So I'm going to go into the table, second graph. And we should see, yes we do, where x is equal to 2, we start seeing errors, which means I've got an asymptote right there. Okay? Well, now let's go graph the second one. And the second function was, I think it was 1/4, and I like to use parentheses anytime I got fractions and stuff. I have found that it ends up graphing it more accurately. I'm going to bring in the log by hitting math, alpha A. And let's see, our log was 1/2 if I'm not mistaken. And again, I like to use parentheses. And let's see, we had x plus 1. And then we got a vertical translation where we're going down by 5 units. And let's look at the graph. All right. Now, the 1/4 has reflected it across the x-axis. Now we have flipped over the x-axis. The plus 1 has shifted us 1 unit to the right. So now I've got an asymptote at -1. The vertical translation has moved us down 5 units. And rather than having an x-intercept, you see now I've got a y-intercept at 5. 1, 2, 3, 4, 5, yes. That flipped us over, and I no longer have an x-intercept, but I do have a y-intercept. And let's go into the table. I probably do have an x-intercept somewhere a little bit greater than -1. But let's go to the table and let's see what we got. Yes, there at -1, we start to see an error, which indicates that we've got a vertical asymptote there at -1. All right, well, that gives us a picture of some translations of logarithmic functions.